Versus radical functions relations, and today we're going to talk about how to solve radical equations and square root inequalities. So we're going to first talk about kind of what is an nth root, what is an index, and then how do I solve when I have radicals. So let's get going. An nth root is a number or an expression that when raised to any power, we call it the nth power, it equals the radicand. So for instance, okay, and that's a lot of weird words. So for instance, this says that since 2 cubed equals 8, we all agree with that, then the cubed root of 8 has to equal 2. That's all that says, okay? The nth power equals the radicand, okay? So 2 cubed equals the radicand. This index, this number right here, that's called the index. So if I had a cube root, this would be your index. If I had a fourth root, then this would be your index. So the one that's kind of misleading a little bit is we already know that that is a square root, right? There's no 2 there, but it's understood to have a 2, okay? So that remember squaring and square rooting, they undo each other, okay? Well, in the same way, if you have a cubed root, to undo it, you raise it to the third power. If you have a fourth root, to undo it, get rid of the radical sign, you raise it to the fourth power. If you have a fifth root, you're going to raise it to the fifth power to get rid of the root, and so on and so on, so that you raise an nth root to the nth power. So what does that mean for us? Okay, well, we're going to use this when we solve radical equations. So the first thing that we're going to do is we're going to isolate that radical, which means get it all by itself. So that means that there's nothing being added or subtracted after it, and there's nothing being multiplied in front of it. Then we're going to undo that index by raising both sides to that power, okay, just like what we talked about on the last slide. Then we're going to solve, okay? Always check for extraneous solutions. They pop up frequently in this process, especially when you have to do more than one powering up. So make sure you check. So let's try one. We're going to solve this radical equation. How do I know it's a radical equation? Well, I have a variable under the radical sign and I have an equal sign. So therefore, I have a radical equation. And what I'm going to do is I'm going to isolate the radical. That means get it all by itself. So I have the square root of x plus 2 is equal to 3. How did I do that? I subtracted 4 from both sides. Subtracted 4 from both sides, just like we've done since pre-algebra. Minus 4, minus 4. All right. Now, I want to get rid of this square root, so I'm going to square both sides. These undo each other, so I get x plus 2 is equal to 3 squared is 9. Now I'm going to subtract 2 from both sides, and I get x is equal to 7. Now just do a quick check. That's all you have to do. It's a quick check. So if I plug in a 7, 7 plus 2 is 9. Square root of 9 plus 4. What's the square root of 9? 3. 3 plus 4. So 7 equals 7. It's that fast to check. So we can also have a radical on each side. You just want to separate them so that they're on opposite sides of the equal sign. And then what you want to do is you want to square both sides. So I'm going to square both sides. When I do that, I get rid of the radical sign. And so I get 2x minus 7 is equal to x plus 2. I'm going to move my x's to the left, so I'm going to subtract, and I get x minus 7 is equal to 2, or x is equal to 9. Okay, so it better work in both sides, right? So 2 times 9 is 18, minus 7. This is my check, okay? And then I have the square root of 9 plus 2. Well, this is the square root of 11, and this is the square root of 11. So it checks just fine. This is your solution. All right, we can do it with higher powers, not just square roots. We've done square roots before. So now we're going to, again, isolate the radical. So now I have the cube root of 4x plus 1. And I'm going to add 2 to both sides. And that's going to give me 4. Now, I have to power up both sides. I got to power it up to 3. So I'm going to cube both sides. Whenever I power up the same as the index, then they undo each other. So you actually end up with just like exponent of 1. So I have 4x plus 1 is equal to 64. Now I'm going to subtract, and I get 4x is equal to 63, and x is equal to 63 over 4. If I plug it in, 4 times 63 over 4, well, that's just 63, plus 1 minus 2. So these cancel, and I get the cube root of 64 minus 2. Well, that's 4 minus 2, so that equals 2. And it checks 2 equals 2. So there's lots of applications in the physical world with this square root property. One of them, which is kind of fun, seeing as we're in basketball season, says the hang time, which is the time in the air for a person jumping like a basketball player, is given by the formula t equals 1/2 or 0.05 square root of h, where t is the seconds that they're in the air and h is the height in feet. So Michael Jordan once had a hang time of 0.928 seconds. Use the formula to calculate how high he jumped. Okay? So I'm just going to write my formula, and I'm just going to write a half, same thing, okay? I'm going to plug in I'm going to isolate my radical, so I get 2 times 0.928 is equal to the square root of h, and 2 times 0.928 is equal to 1.856. Now I'm going to square both sides. And I get 3.445. Okay? And so I'm going to convert that. It's 3 feet and then 0.445. So 0.445 is about 5 inches. So I get 36 plus 5.3 inches. So I get roughly 41.3 inches is how high. So now I thought, okay, well, is that legit? And it is, because actually Michael Jordan has one of like the records for just a standing vertical jump. His standing vertical jump is 48 inches. So you would think that he would get higher with running, but actually the running makes him have more forward progress instead of upward progress. All right, now we're going to change gears a little bit, and we're going to solve square root inequalities. We're going to do a lot of the same thing. We're going to isolate the radicand, then we're going to raise each side to the power indicated by the reciprocal. In this case, these will all be square roots. We're going to solve, and then when we're doing inequalities, we have to be careful that the range of x's that we allow doesn't include anything that lets the radicand go negative. So we have to find what's called a lower limit. So underline that word lower limit. I'm going to show you how to find it. It's very similar to finding that initial point. We need our radicand to be greater than or equal to 0 and figure out what that x value is. All right. So let's start here with 3 plus the square root of 5x minus 10 is less than 8. This lower limit is super important whenever you have a less than symbol, because that's most of the time when you have to protect yourself from your radicand going negative. I'm going to isolate, and so when I do, I get the square root of 5x minus 10 is equal to 5. I subtracted 3 from both sides to get there. Okay. And now I'm going to power up. I'm going to square both sides. So I get 5x minus 10 is equal to 25. I'm going to solve. I'm going to add 10 to both sides. So I get 5x is equal to 35, and I get x is equal to 7. Now notice over here what I did. Circle this. Circle this. All I did was set my radicand greater than or equal to 0, and I solved. And that means that the lowest number that my x's can take on is 2. So here's what I'm going to do. I'm going to put my lower limit on a number line, and I'm going to put my solution on a number line, and I'm going to check some intervals. If I put in a 0 here, I'm going to check something in this section, something in the middle section, and something on the right. Okay, so for the left section, I'm going to check 0. If I plug in a 0, my radicand goes negative, so that can't be a solution. If I plug in a 4, let's just say I plug in a 4. 5 times 4 is 20. 20 minus 10 is 10. 3 plus root 10. So what do you get when you do 3 plus the square root of 10? You get 6.16. Is that less than 8? Yes. So I'm going to put a big check mark there. That's a good thing. And then I'm going to check in a point outside here, greater than 7. So let's say I check 8. So I have, if I put in 8, that's 40 minus 10, so that's the square root of 30. So I have 3 plus the square root of 30, and that gives me 8.5. Is that less than 8? Nope, so it can't be there. So my solutions have to be between 2 and 7, and that's how we write it in interval notation. All right, why don't you try this one for your video question, and then come back and check your work. I'm going to isolate, so I get square root of 2x plus 2 is greater than or equal to 4. I'm going to square both sides, and I get 2x plus 2 is greater than or equal to 16. I'm going to subtract 2 from both sides. 2x is greater than or equal to 14. I'm going to divide by 2. X is greater than or equal to 7. I'm going to check my lower limit. X is negative 1, and my solutions are greater than 7. All right. So let's, if I check negative 1, if I check negative 2, my radicand goes negative, so that doesn't work. If I check 0, I get the square root of 2 plus 1. Square root of 2 is about 1.4 plus 1, so that's 2.4. 2.4 is not greater than 5, so this doesn't work. And if I check 10, because it's bigger than 7, I get 22, root 22. And then plus 1. So I get 5.69, so it works. So my solutions are 7 to positive infinity. That's the solution to my inequality. These are the assignment that we're going to watch, that we're going to work on tomorrow. Thank you for listening, and I will see you tomorrow.